everyone. This is Sir R.J. Dayson, one of the Batalino's teachers. Now for today, we will discuss all about zero and negative integral exponents. Now there are 4 topics to be discussed in this lesson. Let us discuss first the illustrating expression with zero and negative exponents. Now under here, we have 2 rules to be followed. First is the zero exponent rule. So let's start with this one, where a raised to 0 is equals to 1, where your a is not equal to 0. So the zero exponent rule is a result of the quotient rule for the exponents when it is applied to an exponential expression with equivalent numerator and denominator. Again, remember, dapat the same ilang numerator and denominator and also their exponents. So we have here a given a raised to m over a raised to m. That means they have the same base and the same exponent. So we have here quotient rule of exponent. So we have a raised to m minus m. So we have a raised to 0 that is equal to 1, where a is not equal to 0. Okay, we need to take note that whenever your 0 raised to 0, it is undefined. Okay, let's try example number 1. So we have 3 raised to 0. Okay, we need to remember that any base raised to 0 or any number raised to 0, that is equal to 1. Number 2, we have x raised to 4 over x raised to 4. So we have here, we follow the rules in the quotient rule of exponent. So we have copy the base, we have the same base x, and then the exponent, we have the same 4 minus 4. So we have x raised to 0 that is equivalent to or equal to 1. Okay, let's try this one. So we have 4 raised to 0. Then we have x raised to 2 times 0. So we have 4 raised to 0, 1 times we have x squared raised to 0, 1 that is equal to 1. Okay? Are we good with the zero exponent rule now? So let's proceed to negative exponent rule. So we have here a raised to negative n equals the reciprocal of its base. So we have 1 over a raised to n, where your a is not equal to 0. So we have 2 rules to be discussed in negative exponent rule. So we have here the first rule is the negative exponent rule states that for every number of a with the exponents negative n, take the reciprocal of the base and multiply it according to the value of the exponent. So we have here a raised to negative n. So we need to find the positive reciprocal. So we have 1 over a raised to n. So it will come, the n here, the negative n will be in a positive na, where your a is not equal to 0. Let's try example number 1. So we have here 3 raised to negative 2. So we will find first the reciprocal of 3 raised to negative 2. So we have 1 over 3. Then the exponent, negative exponent, we will now change that into positive. So simplify. So we have 1 over, so 3 squared, 3 times 3, we have 9. So we have here the answer for the 3 raised to negative 2. So we have here 1 over 9. Let's try example number 2. So we have here, find the reciprocal of 2 raised to negative 4. So we have 1 over 2. And then the negative exponent will change into positive. So we have 4. So we have 1 over 2 raised to 4. And then simplify. So we have 1 over 2 times 2 times 2. So we have 2, 4, 8, 16. So we have here 1 over 16. Then last one, we have a raised to negative 3. So we have here, find the reciprocal. So we have 1 over a raised to positive 3. So that's the final answer. Okay? I hope that you understand the rule number 1. Okay, let's now proceed to the second rule for the negative exponent rule. So we have the second rule. The rule for a negative exponent in the denominator suggests that for every number a, or our base, in the denominator and its exponent is negative n, the results can be written as, so we have here 1 over a raised to negative n equals a raised to n, where your a is not equal to 0. So all you need to do here, class, is you need to find, again, the reciprocal. So we have here the result, 1 over a raised to negative n. So that means if a reciprocal, so we have a raised to n over 1 actually, then you will change your negative value of your exponent to positive. So we have here the answer or the result, a raised to n. So let's try example number 1. So we have here 1 over 3 raised to negative 2. So you need to find the reciprocal for that one. So we have here 3 raised to 2 over 1. Or we have 3 raised to 2. So we have the result 9. Example number 2. So we have 1 raised to 5 over 5 raised to negative 3. So we have here find the reciprocal. So we have 5 raised to positive 3 over 1. So we have 5 raised to 3. So we have 5 times 5, 25. 25 times 5. So we have 25. And 125. And then last example. So we have 1 over 2 raised to negative 3. So we have 2 raised to negative 3 over 1. Positive 3 over 1. So we have 2 raised to 3. So we have the result 8. Okay, now since we've already discussed the zero and negative integral exponents, we will now try to combine both of them by using and also including operations. Okay, let us apply the zero and negative integral exponents rules in the following example. So we have here example number 1, 6 raised to 0 plus 2 raised to 0. So we have here, we will use zero integral rules. So we have here 6 raised to 0. So whenever your value raised to 0, that is equivalent to 1, plus, then we have 2 raised to 0, which is also equivalent to 1. So we have 1 plus 1, so the result is 2. Okay, let's try example number 2. So we have 1 over 5 raised to negative 4 plus 1 over 3 raised to negative 3. So we will apply here the second rule for the negative exponent rule. So whenever your fraction form, and then your denominator is in the raised to negative, so you will just reciprocate the given value, and the numerator and the exponent will be in a positive form na. So we will try this one. So 1 over 5 raised to negative 4. So we have 5 raised to positive 4 over 1 plus, then we will also reciprocate this one. The second, we have here the second value. So we have 3 raised to positive 3 over 1. So we have here the result, 5 raised to 4 plus 3 raised to 3. So we have here 5 times 5 times 5 times 5, or 5 raised to 4, it is equal to 6 to 5. Plus 3 raised to 3, 3 times 3, 9, 9 times 3, we have 27. So we have the result, 6 to 5 plus 2, 27. So we have 12, 5. So we have 652 as your final answer. Okay, let's try example number 3. So we have 2 over 10 raised to negative 3 minus 2 over 6 raised to negative 3. So we will now find the reciprocal for the denominator first. So we have 2 over 1 over 10 raised to positive 3 minus, so we have 2 over 1 over 6 raised to 3. Now we're going to do here, class, is we need to find the reciprocal for the denominator here, and you need to multiply that to our numerator. So we have here 2 times, what is the reciprocal for 1 over 10 raised to 3? So we have 10 raised to 3 over 1 minus, multiply the numerator to the reciprocal of your denominator. So we have 6 raised to 3 over 1. Okay. Now we need to simplify the given. So we have 2 times 10 raised to 3. 10 times 10 times 10. So we have 1,000. Minus 2 times 6 raised to 3. That is 6 times 6, 36. 36 times 6 is 126. So we have here, simplify 2 times 1,000. So we have 2,000. Minus 2 times 126. So we have 126 times 2. So we have 12, 4, 5, 252. Now subtract 2,000 minus 252. The result will be 1,740. So that's how you apply zero and negative integral exponents. Okay, that's all for today's lesson. I hope that everyone learned something about zero and negative integrals, and the rest of the topics will be discussed in the next video. Thank you so much for watching. Please like and subscribe. Thank you so much, and annyeong.